In this lesson, we're going to have to think about the different types of software. We've looked at these previously, and these include application software, general purpose software, and special purpose software. Make sure you have an understanding of these. In this lesson, we're going to be thinking about software development. What do you think software development methodologies means? In this lesson, we're going to be looking at the different types of software development, the pros and cons of each of the different types, and then the drawbacks and how to use them to write algorithms. Here are the key words that we're going to be using during this lesson. Task number 1. I want you to make this dog just using paper. You've only got 1 minute to do it. Who can get the closest? We need to be careful and make sure that we plan before we actually start creating software. Otherwise, we're never going to be successful. And this is why we have software development, so we can make sure that we set out our goals correctly at the start of a project so that we can end up with the project outcomes that we wanted. Your first task is to go through the different stages and see if you can put them in order. Go to the workbook and try to complete this. Here are the answers. Make sure you fix any errors that you've made. Now, to start with, we're going to generally think about the different stages of a random system lifecycle. There are different methodologies and different ways of completing software projects, but we're just going to have a look at some of the common stages first. We have a Unit 3 project link here because when you start making your project, you're going to have to complete several of these different stages. First of all, we're looking at the feasibility study. A feasibility study is a really important task. We need to figure out if the problem is actually worth making. Is it achievable? Is it going to be too expensive? And do we have the technology to actually do this? There might already be something out there that does a similar project, which would save us time and money. We can think of the feasibility study within 5 different areas. First of all, the technical feasibility. This means, does the technology exist to implement the proposed system? Are we trying to achieve something that's not technically possible at the moment? The economic feasibility, how expensive is this going to be? If we've got a budget and we're a company, is this actually going to give us the benefits that we need for the cost? If it's too expensive, is it really worth it? The legal feasibilities. Is this actually going to fall within legal guidelines? Or is it going to break some data protection acts? Or are there some that we're going to have to take into consideration when we make the project? The operational feasibility is having a look at current work practices, so within a business. How will this system support our current working? There's also a social factor here. Will it affect the work lives of those using the system? If it's going to add hours onto people's time, then it's probably not going to be worth it. And then finally, our scheduling feasibility. How long is it realistically going to take us to make this? If it's going to take years and years, well, is that going to be the correct solution for us? Remember that there might already be a system that's currently similar. We may want to research other systems first. Usually at the end of this stage, we create a report, sometimes called a feasibility report. If the report concludes the project should go ahead, then this would usually be agreed by senior managers in a company and the clients. This means then a detailed requirements analysis is likely to be produced. You can find information out about a systems analyst and the job using the links on the screen. You now have a task to complete. I want you to complete a feasibility project for the following scenario. There's currently a lack of interactivity for gesture control of computer systems. This is important for hospitals when hygiene is critical. Some hospitals want patients to be able to interact with computer systems without touching them. For example, bedside entertainment systems, hospital appointment bookings, and interactive maps. Use the page in your work booklet to actually try and create a feasibility study for this. This is the page you are looking for. Please pause the video and complete this task. Now, first of all, the technical feasibility. We have to think about what hardware and software is going to be needed. That's going to have to be cameras. We're also going to have displays and screens. There might be an element of artificial intelligence and recognising hand positions, which needs to be included as well. We might actually also think about what systems are already out there. Are there systems out there already? And there might be similar systems. What about voice recognition? Would that work better in a hospital? Would that support more people? What about disability friendliness of the system? The economic feasibility. Is this going to be expensive? Are web cameras expensive or cameras expensive? Are displays expensive? And is the software programming going to be expensive behind that? Well, generally speaking, our cameras are quite low cost nowadays, a cheap webcam. There are systems where you can quite quickly create artificial intelligence using hand gestures. So it is fairly economic and economically feasible. The legal feasibility. Now this is an interesting one. When you are taking pictures of people in a hospital, do they give you permission to actually have them on the screens? What are we going to do with that data? Are we going to store that data? Or is that data going to be deleted once we've finished with it? Our operational feasibility. How easy is it going to be for us actually to create this system? Is it going to meet the needs of the hospital, or do we need to think about other disabilities and how we might include voice feedback into this system? How easy is it going to be to install this system? Will it be accepted by members of staff? And what happens if it breaks? Is this going to make it easier for staff in the hospital? Well, actually it might be, because we might actually be able to automatically sign people in and out of appointments. But there'll only be certain people who can do that. Think about A&E. If you've got somebody who's injured, then unfortunately they're not going to be able to access this system. And the schedule feasibility. Well, if we're thinking about this, how long is it going to take us to create this project? Well, we'd be looking for maximum probably 6 months. The next stage is the analysis stage. We need to create a more detailed report which focuses on the current systems and the requirements of the new proposed system. It's actually the systems analysis job to find out about current methods, user requirements, and assess the feasibility of a project. If we're building a system, we want to make sure that it fits in with the company. That means we have to probably go and interview staff. What do different staff want from the system? What do the senior managers want from it? And we probably have to look at current businesses and system documents. What are they outputting of their system to make sure that our system matches the automated product that we are creating? We might want to send out questionnaires, speak to staff and analyse those responses. Look at any concerns. We might even go and observe some of the current practices going on within the business. Once we've done this, we're probably going to create a report. We're going to examine how data flows through the organisation. Who uses what data, how they use it, and why that's important for them. We might at this point show costs and the benefits of the system. So why would we want this? Is it going to save time? Is it going to save the company a lot of money? We might explain how the system actually will be implemented. What would be the best way to implement it so the business that we're working with feels confident that we are putting in a correct system. We might explain who the users are, which user in particular is going to get which information and in what format. Only once the first two sections have been completed should we move to the design. It's often that if the analysis and feasibility is not done correctly, then the design stage may have to be redone if the client is not happy with the designs of the system. The design stage is taking the concept and turning it into something more visual that the user can actually understand. There might be multiple solutions that you might want to investigate, or different solutions that the user might choose between, different user interfaces, for example. We might need to actually then go back to the client to decide which one they prefer. We often create diagrams and comments of the system to give us more of a visualization. For example, here is a data flow diagram. We can have a look at a new network implementation, and we can see what devices are going to be connected to it and the layout of these. We need to make sure that data is flowing correctly around our system. And here are a few more examples of data flow diagrams. You can see the different stakeholders that are invested in the system and how that data moves between them. We might create wireframe designs, navigational designs, or basic sketches of the system. This will help us to show the flow of the system, where different things will lead to, and again how data will flow in a more visual way through our computer system. One of the most important parts is the user interface. What will it look like to the user? We finally want to think about data validation and verification. On the next slide there's a task. I want you to think of the validation rules you might implement for the gesture system. I want you to think about the validation rules. Pause the video and try and complete this task. Now there should be lots of different options here. For example, do you want a confirmation once the user has given you their gesture? That might be a simple thumbs up or thumbs down. There are lots of different validation that you might have come up with. We need to think about the data volumes. Can our system handle a large amount of data? And there's a news article here linking to a new piece of parents' evening technology. This parents' evening technology did not manage to succeed when lots of parents all of a sudden jumped on the system. That's because it hadn't been successfully tested. You also need to think about functional descriptions of the procedures, modules and functions so that a programmer could pick up this piece of work and it could be produced. So how will the code be split down? And then finally, a test plan. This is one of the most important things that we're going to create at this stage. We need to predict the outputs and make sure we plan to handle any errors. So why create a test plan at this stage? Why not do it afterwards? First of all, I want you to watch this advert. So I want you now to think about why was this advert banned? First of all, nowadays you can't put anything which is high in salt or high in sugar on the TV before a certain time. And secondly, it was deemed to have poor taste because it was deeply offensive and trivialised the work of animal welfare charities and child protection agencies. Well, this advert actually cost £2 million to make, and this was in 2013, remember, so quite a lot of money. And it was first shown during Coronation Street at 7:45. This caused a lot of complaints, and they ended up having to donate money to the RSPCA. So how could this have been avoided? Well, they should have created a test plan, and they should have checked with the target audience and their responses first. Did it have an appropriate design? Was it suitable for the time it was shown? And there might have been other things that they could have thought about in the validation. Usually, at the end of the design stage, again, you would consult with the client. They might have some design decisions to choose. There might be different logos, colour schemes, user interfaces they have to choose between. However, you should be able to, at this point, give your documentation to any programmer so that they can build it exactly as you've given them instruction to. They shouldn't need any other help than what is needed with the design documentation. So if you think they need help, whether that be with the user interface, the flow, or the outcomes, then there's not enough information in that design stage. The next stage is the implementation of the project. During the implementation stage, the project development team will take over. They will use the design documentation to create an actual product. Don't get confused with the installation. This is not installing a product or a project. This is actually creating it. And this stage will be only successful if the design stage was carried out properly, and usually would be given to the clients to check first. It's at this point you'll have invested a lot of time and effort and money, so there might be different parts of implementation, and during this stage the client might continue to be involved. Next, we would have testing. We should now follow our test plan that we created earlier on in the project. A company needs to ensure their reputation is good, and we don't want to be installing a system into a new company with a product which isn't going to work and meet their needs. If it has bugs, it might mean they lose money. A good program will gain in popularity if customers see it as a good program, and a bad system might not only damage the reputation of the company, but it also will damage your reputation as a software developer. Here's a quick video to talk about software when it goes wrong. The next stage is the installation. Now, installation is not a simple stage. It's not as simple as you would think, because if you have a customer, you want to minimize disruption. You need to think about staff training. How can they get used to the system? How do you get any data from an old system into a new one? Is it needed to do that? How long will it take? What happens if the current system fails? And any software or hardware which needs to be installed needs to be purchased and installed. So there are 4 different ways that we can do this: parallel running, pilot running, direct changeover, or phased implementation. You're going to pick a specialism and then explain it in your workbooks about which specialism you have. Think about what it actually is, the pros, cons, and any limitations. Once you've completed your section, everybody else in the class will be presenting theirs. The first one is parallel running. That means we have 2 systems running at the same time. We turn the new system on, but keep the old system on in the background. This allows us to prove that the new system is doing what we want it to do before shutting the old system. We know the old system is trusted and is working, and the new system should hopefully take over as long as it keeps working. This means the staff can actually get used to a new system as well, but it's doubling their workload. They've got to do everything twice. But once everything's okay, the old system will be shut down. We might also get data discrepancies here if somebody's forgotten to put something on one of the systems. When you're running a pilot system, it might be that certain parts of a business or certain portions of a system are run in parallel at the same time as the old system. When you're happy with the system, it might be that then is given to the whole company. Think of a supermarket. If you're installing a new checkout system, you might decide a couple of branches are going to trial that before using it for everybody. Or within one supermarket, you might have one till using that system to check it's running as you want it first before the rest of the company use it. A direct changeover would be when you shut down an old system and start operating a new one straight away. You need to have staff training available well in advance so they know how to use it, and you might have a test system so they can check this, but it wouldn't be live with data. However, the issue is if something goes wrong, you can't fall back on the old system. In a phased implementation system, parts of the new system will replace parts of the old system. Parts of the new system can be used for staff training before the next part is actually installed. This will take a long time compared to some of the others, such as direct changeover. You might do one part at a time, and it might actually include an element of parallel running. You might do a direct changeover or parallel running of part of the system, but small phased inputs. The next stage is the documentation stage. Now, sometimes this stage will happen concurrently with our implementation. This is any documentation which is used for the end user. That could be program specifications, security details, how to use it, and user guides can take many forms nowadays, including video and booklets, text and demonstration. You can break this down into either user documentation for somebody who's using it, or technical documentation, potentially for technicians who might be installing, fixing or maintaining the system. Our final stage is the evaluation and maintenance stage. Now, just because a system has been installed, it doesn't mean that it's going to be the end of the actual system's life cycle. There might be maintenance that has to carry on. That might be because there's a bug or a flaw in the system, or some work practices change. Think of your phone iOS. You constantly have updates, and these address some of these issues. Bugs in the system. The laws might have changed about how data can be used. New technology might be released, and you might want to implement that with the system. The customer might need extra functionality, which means that you're going to have to build new parts or change the system. Or the business expands and it's going to need to handle more data or more users. And finally, evaluation shouldn't be forgotten. As a project development team, you need to make sure that the customer's happy. Is there anything that you've missed? And a good project will evaluate all the way through. But as a development team, at the end of a project, we need to evaluate our working practices. Did things go well? Did we spend enough money? Did we save money? Where could we have done better next time? Were we accurate? Was our process good enough? What are we going to change for the next customer that we have? These are some of the evaluation questions that you could use. Does the system meet the system requirements that you were set out right at the beginning? Does it contain any bugs which need to be fixed? Does it crash? Is it actually making employees more efficient? Did it meet its purpose? Did the selling price pay for the work that was done? Did we lose money or did we make money? Are employees confident using the new system? So, in recap, our feasibility study is a basic analysis. Is it worth actually completing the project? Our analysis is a detailed analysis, checking the requirements of the system and the flow of data. Our design section looks at creating designs for the solution. We might redesign different sections, and there are different types of designs that we might use. Implementation is basically creating the system. Testing is where we test our system using the test plan that we have created previously to see if it works as expected. Are there any bugs? Is there any functionality not working? Is there anything else we still need to improve before we hand this over to a company? Our installation is actually installing the system. Remember, there are different ways that we can do this. We can create user documentation for the end user to support them either technically or for their users. And finally, the evaluation and maintenance section. This is where we maintain the systems, improve them and update them if necessary, and evaluate not only the system but our own working practices. Next lesson, we're going to be looking at some different methodologies. The stages we've looked at are just general stages and will appear in most of these methodologies. When designing a project, though, there are different ways that you can go about ordering some of these, and we're going to look at these next lesson. Just to note that you're going to need to choose one of these for your project. So you're going to need to know the stages and you're going to need to know the different methodologies.